Welcome to this mathematics tutorial. I'm Charles Umagu. In this video, we want to learn about number base. And we know that the number base is a number of digits in any counting system. And we say there are many counting systems. We have binary, we have quinary, we have ternary, we have octal, we have decimal. And the most common counting system which we know or we are conversant with is the decimal and the binary system, which is applied in our computers. Right, in our first activity today, we want to learn how to convert numbers from other bases to base 10. That is conversion of numbers in other bases to base 10. So let's take an example. Convert 2034 1 202 and 2 1011 to base 10. So we have two examples to use to show how to convert numbers in other bases to base 10. The first one is a number in base 4, which we can see the 4 there as a subscript. How is that done? We say this is 2034. Let's say this is, since this is numbers are in base, this number is in base 4, we have just written 4 on top of it for clarity, and we start numbering to the left from 0, 1, 2. So we are going to use the expansion method. And how is that done? We say this is 2 times 4 raised to the power of 2. Let's put it in bracket for clarity. 0 times 4 raised to the power of 1 plus 3 times 4 raised to the power of 0. Okay, we clear brackets. 2 times, this is 4 raised to the power of 2, which is 16, plus, okay, for now. 0 times 4 raised to the power of 1 is 4, plus 3 times 4 raised to the power of 0 is 0, because 8 raised to the power of 0 is 1. Sorry, 4 raised to the power of 0 is 1. Okay, 2 times 16 gives us 32, plus 0 times 4 is 0, plus 3 times 1 is 3. So what we have there is 32 plus 0 plus 3, and gives us this gives us 35. So 203 to base 4 when converted to base 10 is what? 35. Let's take the second example. Hope you get it. One 0 1 1 2. This is a number in base 2. The task ahead is to convert it to base 10. Again, this is base 2, and from here we number to the left. This is 0 1 2 and 3. So we expand again. This is 1 times 2 raised to the power of 3 plus 0 times 2 raised to the power of 2 plus 1 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 0. This is equal to 1 times 2 raised to the power of 3 is 8 plus 0 times 2 raised to the power of 2 is 4 plus 1 times 2 raised to the power of 1 is 2 plus 1 times 2 raised to the power of 0 is 1. So it's equal to 1 times 8 is 8, plus 0 times 4 is 0, plus 1 times 2 is 2, plus 1 times 1 is 1. So we add 8 plus 0 is 0, 8 plus 0 is 8, plus 2, 10, plus 1, 11. Therefore, 1011 to base 10 is 11 to base 10. Hope you get it. The next activity is to show you or to demonstrate how to convert numbers from base 10 now to other bases. This conversion from base 10 to other bases. Now we have a number in base 10. We want to change it to other base. Let's see. Let's take example. Convert 120 to base 3. This is the first one. The second one is convert 34 to base 2. Let's take them. The first one is 120. So we are going to use the long division method. So by repeated division. So we have 120. We are going to divide it by 3 continuously. So this is 3. 3 goes into 12 is 4 into 0, 0, there is no remainder. 3 goes into 4 here, 1 into 10 is 3, remainder 1. 3 goes into 13 is going to be 4, which is 12 times, remainder 1, which is 12, remainder 1. 3 again will go into 4, 1, remainder 1. Now we 3 again into here is going to 0, remainder 1. Alright. So now we are going to read the numbers, the answer from the bottom to the top. So we have 120 to base 10 is to base, in base 10 to base 3 is going to be 11110 to base 3. That's the final answer. Hope you get it. Let's take the second question. We have 34. We have to convert it to base 2. Okay. Again, we are going to use the repeated division. This is 34. This is 2. 2 goes into 34. It's going to be 17. There is no remainder. Remainder 0. 2 again. 2 goes into 17. It's going to go 8 times. Remainder 1. 2 goes into 8. Going to be 4. Remainder 0. 2 goes into 4. 2. Remainder 0. 2 goes into 2. 1. Remainder 0. 2 again here. 0. Remainder 1. So as it was in the first case, read the number, the answer from bottom to the top. Therefore, we say 34, which is a number in base 10, when converted to base 2, is 10010. Okay. There's what is called bidecimals. Bidecimal are base 2 fractions, such as 1.11.11.110. These are base 2 fractions, and we know that we also have decimals, which is our base 10 fraction, like 9.43, 6.66.21. These are all decimal fractions. Bidecimal can be converted to decimal by some operations and by method of expansion. We can convert bidecimal to decimal. Let's take an example. Convert 11.101, which is a bidecimal, to decimal. Right? This one looks tricky, so just be attentive, you get it. So here we have 0, 1. Here to the right, we have minus 1, minus 2, and minus 3. So this is going to be, remember this is bidecimal, which is base 2. So this is going to be 1 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 0 plus 1 times 1 times 2 raised to the power of minus 1 plus 0 times 2 raised to the power of minus 2 plus 1 times 2 raised to the power of minus 3. Progress. 1 times 2 raised to the power of 1 is 2, plus 1 times 18 raised to the power of 0 is 1, plus this is going to be 1 times, this is 2 raised to the power of minus 1, this is going to be 1 upon 2, plus 0 times 1 upon 2 raised to the power of 2, plus 1 times 1 upon 2 raised to the power of 3. Okay, we progress. 1 times 2 gives us 2, plus 1 times 1 is 1, plus this is half. 1 times half, this is half, that's 0.5, plus this is 1 upon 4, plus 1 times 1, okay, 1 upon 8. 1 times 1 is 1, 2 raised to the power of 3 is 8, 1 upon 8. Okay, let's convert all of them to decimals. It becomes 2 times 1 plus 0.5 plus 0.1, 0 times 1 upon 2 raised to the power of 2. This number was multiplied by 0, so it's gone. So what we are going to have there is plus 1 upon 8, which when converted to decimal is 0.125. Alright, we add all the fractions, or we add, this is 2 plus 1 is 3, plus 0.5 plus 0.125. This is going to be, let's add it somewhere, 3, 0.5, 0.125. This is 5, this is 2, this is 6, and this is 3. So our final result is, so it's our addition, final result is 3.625. Okay. Next video, we want to deal with the addition, subtraction, and multiplication of binary number. Stay tuned and subscribe to the channel. Thank you.